to start?
Yeah, so I think the time is
Yes,
up.
sir.
So can we
Yeah.
start? What?
Yes, sir, yes, sir, yes, sir. Yeah. Kurat, you can start. 1 second, sir. Yeah.
Welcome back to the 1 week workshop on 5x CNC machine. This session will be conducted by Dr. Amrut Sherikant Mulay. Dr. Mulay is an assistant professor, Department of Mechanical Engineering, Sadar Vallabhai National Institute of Technology, Surat. Before joining the institute, he completed PhD from National Institute of Technology, Warangal, India. He was one of the few PhD students from NIT Warangal who got selected for prestigious interview program under the Erasmus Mundus Fellowship Project fully funded by the European Union. He has carried out part of research work at Warsaw University of Technology, Poland. He has published a good number of papers in reputed journals and conferences. His major research interests are incremental forming, unaxial and biaxial cruciform, citrus-citrine field, digital image correlation, optimization of manufacturing processes, and finite element studies in manufacturing, etc. With this brief intro, I request Dr. Mulay to begin his lecture. Over to you, sir. Sir, you aren't audible.
Sir, your mic is muted.
Yes. So I'm very much happy. And may I know the name who has given introduction? Please. Huh?
Meet
Kurat, Kurat, Kurat.
Pratlan.
What is the name?
Purat.
Okay. Thank you, madam, for the introduction.
Thank
Uh,
you, sir.
and yeah, I'm very much happy to be here, and it's my honor to present in such a prestigious institute at NIT Srinagar, one of the premier institute in our country. And I'm very much thankful to head of the Department of Mechanical Engineering, director of NIT Srinagar. As I can see from your profile, Professor, I'm very thankful to Professor Rakesh Sehgal, Professor Nazir Ahmed Sheikh, Professor M.F. Wani, Professor G.A. Harmin, Professor M. Maharuf Wani, Professor Babar Ahmed, Professor Adnan, Professor Sheikh Saeed, Professor Saad Parvez, Dr. Hanif, Dr. M.S. Charo, Dr. Muhammad, Dr. Mukund, Dr. Hanveer, Dr. Muhammad Khan, Dr. Noor Zaman Khan, Dr. Abhijit Dey, Dr. Manoj Kumar, Dr. Ved Prakash, Dr. Dinesh Kumar, Dr. Sandeep Rathi, Dr. Deepak Kumar, and last but not least, Dr. Dinesh Rathod. I'm very much thankful to all the dignitaries present over here and all the student member and friends. Today, I am going to present my topic on incremental sheet metal forming applications. I'm working in this area from last 7 years, starting from my start of my PhD. Ample amount of publication has been sought so far, and the attempt is made on publishing more article, going in-depth research in the field of forming technology. We are here at NIT Surat will not be limited only for the incremental kind of forming, but we are attempting all different kinds of forming, including deep drawing, and non-conventional forming, non-conventional metal cuttings, including viridium, deep drawing, simulations in abacus. We are also working on hydroforming. So some of the we are working on metal formings and preparation of customized implants. So now the requirement of the industry is industry 4.0, and we are looking for customized implant. We don't want a conventional type of parts to be manufactured at our end. So we are very much interested in customized implant. So the session which I would like to take, I feel that I should comprise of small content, but I think it should be understandable to all of you. So my topic of content is I will share some slide, and it, the lecture would not be complete if I don't show you some demonstration, right? But all the package has to be completed in the period of 1.5 hours. So this time we have to manage. So what we do is, say first half an hour, so first 1 hour, I will dictate you, or I will explain you the theory behind in farming technology, and the final half an hour remaining will be taken by my student, Mr. Dinesh Dishant, sorry. He will going to take you some practical demonstration of farming technology, right? So I hope that this particular session will be helpful, and at the end of the session you will you can take away something in your practical knowledge. So my particular philosophy is to give some inputs to you so that you can further excel in this area, and also there should be some fruitful discussion, right? You should understand something, then only you say that somebody will come, somebody is from SVNIT Surat and he delivered some lecture and we got benefited. So this is what agenda. But again, as per the time limitation, we cannot go much in detail. But if you at all you doubt, you last 10 minutes will be provided for discussion, right? So without wasting much time, I share my screen with you, and just if you have any doubt, we'll discuss at the end. I shared my screen with you. Yes. So now here, so here, so we will be taking 1 minute. What we do is, instead of this, we can have some another PPT with me. I think that would be fine again. NIT Srinagar. Yes. Now this topic is, see, the flow of presentation we do like that, and so the first this technology, I just quickly go to the introduction. This Maison has proposed this technology. Later on, it was US patented. From 1980, this technology is evolving. You can see in the 1978, and I would see that last 2 decades we found a rigorous work in the field of farming technology, especially ISF farming, right? So people are used to make different kinds of prototypes, different types of parts to be manufactured. So the sheet metal parts are not only used in automobile, biomedical, but it in variety of applications. And many times you need a very small number of components. And if you go to the um, punch punch and die type of forming technology called conventional type, it takes a long time to prepare the die, and also for the less number of production, the per cost of the per part, so per unit cost of the product will increase drastically. So therefore, the people are looking at customized production, and the customized production can be obtained using a customized program, right? And customized program you can generate using CNC code, right? So again, I go to this. You can see that the motivation behind this technology is the heterogeneity. What is in my heterogeneity is every part is different from other, and it has versatile application. You can see the cranial implant. The cranial implant is the biomedical application, right? I will show you some of the application. Even you can see the bullet train. One of the part of the bullet train, 1/8 of the scaled model of the Shinkansen bullet train. This is the Japanese bullet train. 1/8 model means every dimension is reduced by 8th time. So if it is dimension is 100, so 100 divided by 8 will be the actual dimension. So reduce the size just to make a prototyping. So rapid prototyping is one of the uh, major concern of using this SPF technology. Even the Ford logo, you can see the Ford logo is also manufactured by using this technology. So how to prepare these kind of products? We can see actual videos and some demonstration. So you can see that there will be a clamp and support, and there will be one tool. So the tool is different types. Sometimes people have worked on flat tool. the tool. No, you can see the tool. Tool is not hemispherical. It is not always hemispherical. Tool sometimes a elliptical or a flat tool. So there is a clamp. So clamp is used to hold the sheet with respect to a support. And it will take a z direction. Moment is in the z direction. And there will be moment in the x direction too. You can see there will be two moments. There will be two moments. X, y and z. Right? There will be two moments. So now here the axis shown x, in the screen, whatever perpendicular axis to the screen is the y-axis, So you understand. So this is the setup. What we practically we can see this setup as like this. Now you can see that what happens to the actual CNC machine. Now you can see your topic is of CNC. Now CNC machine is look like this. So this is a punch, and which deform the sheet material. So definitely when there is a sheet material getting deformed, so there will be initially there will be bending. So the phenomenon of forming is bending, stretching and bending. So material is stretch. Material is stretch, and due to material will stretch, material will be deformed, so there will be thinning. So there is a drastic difference between the metal cutting and metal forming. The total volume remains constant in case of metal forming, but it is not true in case of additive or subtractive manufacturing technique. In case of subtractive and additive manufacturing technique, always the volume remains. Volume will not be constant always. It will either reduce or add, right? But in the forming technique, where the volume is always constant. What is the volume? Volume is nothing but area multiplied by third dimension. Area multiplied by third dimension. So you know more detail about volume. So volume sometimes in some area thickness will reduce, in some area thickness will increase. It's nothing but the very basic principle of elastoplastic deformation, right? Now you see that many theories have developed in this forming. Now you can see that this is a tool which is operated by a CNC machine. A CNC machine is nothing but a robot. So people are using 3-axis CNC machine, 5-axis CNC machine. The 5-axis CNC machine, it has own advantages, but many places you won't find 5-axis CNC machine because it's very costly, very sophisticated. So this particular forming is taking place. We use only 3-axis CNC machine. What is 3-axis CNC machine? Which controlling 3 axes, X, Y, and Z, right? So now you can see that I don't go much detail in the metal forming because the workshop is more inclined towards CNC. So I would just go quickly. The final thickness of the sheet metal, it depends upon the original thickness into sine 90 minus phi. What is phi? Phi is nothing but forming angle. It means that when you form some component, the theoretical relation says that TF is final sheet thickness. So final sheet thickness is here. You can see here at the bottom. The final sheet thickness, it depends on initial sheet thickness multiplied by sine 90 minus phi. Phi is the forming angle. So forming angle you know, phi angle you know, initial sheet thickness you know. Suppose you are preparing some component, the initial sheet thickness is 1 mm or 1.2 mm, that you know. Phi also you know, so T final can be calculated. So this is a rough indication, but again, one thing you would like to always remember: this estimation will always give a clear idea or approximate idea only at the middle portion of the forming. What does it mean? It means that you know this, right? So I have shown you the previous figure. Now you know the stretching zone. This is a bending, stretching, and bending. So only at the stretching zone, this particular relation valid. In initial bending and final bending, this relation is not valid. This relation is not valid. That you must have to understand. And people have tried with the different geometries because the geometry of the part has also an effect on the formability. That need to be investigated. Now you can see that this particular geometry is bearing ball angle conical fractum. What does it mean? It means that when you tangent at any portion of this line, you can see this line. This is the geometry. According to this geometry, this product is being formed. It means that when you tangent anywhere, the tangent angle, this angle phi I will not be same. So here the phi I values ranging from 30 degree to 90 degree. One of the limitation of the incremental forming, that the cylindrical part cannot be produced. The wall angle with 90 degree is very difficult. So one or two cases it is possible, but they use some another technique. They use even you won't get more formability if you increase the angle. So it means that it will, if you make the geometry with 90 degree, within some a span of small distance in the z direction, it will fracture. So fracture has to be avoided in the forming, which is a very big challenge in front of researcher worldwide. Avoiding the fracture. So what are the different ways that you can predict the fracture? The first way of predicting the fracture is the measurement of strain. मेजरमेंट ऑफ स्ट्रेन. अब मुझे ये बताओ कि कभी भी स्ट्रेन जब किसी चीज में आती है तो वो ड्रास्टिक आती है क्या? नहीं. फॉर एग्जाम्पल, we will keep a milk in a, say, some pot, and we are heating into a gas. So you tell me that suppose heat is increased, right? Suppose first temperature of the milk will be a 10 degree, then 15 degree, 20 degree. Slowly the heat, the temperature of the milk will increase, and it reaches to a boiling temperature. At the time of boiling temperature, the milk will boil, right? So it will gradual. So it is called as quasi-static. It is not rapid, right? It is slowly. Again, depends upon the gas intensity. Similarly, here also, in case of forming, the strain will not induced immediately. So strain will regulate. So up to what maximum extent you can prolong the strain, that is very important. Ultimately fracture will happen. So we want to see up to how much time or up to how much height you can make the component in any form. So formability indication of the formability, it has again another topic. That's what I say. I don't want to go, otherwise 1 hour will go in the forming technology. Okay. So using CNC machine, we can have variety of component. So first component is, you can see that the application is cranial plate. Generally, this cranial plate is used for the medical applications where we want to use this cranial plate for accident affected patients. Cranial. Generally, these cranial plates are made up of titanium alloys, magnesium alloys, and steel alloys, because these are biocompatible and these are porous, or we can say perforated sheets to be used. Okay, these are the implants. Even you can find some live application in some articles. We have those articles. If time comes, we'll show you. Again, 1 or 2 application I will show you in the subsequent slides. Now you can see that now you can see the CNC tool is from the top side, and below that there will be sheet, and the program is generated and the sheet is formed, right? So this is called negative forming. Why it is called negative forming? Because the tool is moving in negative z direction. But you can see that there will be second kind of forming. It is called negative forming, and second called as positive forming. Second one is called as positive forming. You can see ये जो बेस लाइन है ना, क्लैंप और सपोर्ट के बीच में जो बेस लाइन है, उसके ऊपर आपकी फॉर्मिंग हो रही है. So this is called positive forming. And I would like to tell that this is also called as B, 2-point incremental forming. 2-point incremental forming, right? Because and more research has to be done, and it is necessary to have this kind of forming, because if you use second kind of forming called 2-point incremental forming, one of the big limitation you will going to avoid, so that is called spring back and accuracy. You will get more accurate product using this second kind of variant of technology of ISF using CNC machine. And the third one is called duplex forming. You can see duplex forming. This particular machine is available in IIITDM Jabalpur. Professor Puneet Tandon is working on it. They got some matrix project of around more than 1 crore, and they developed this kind of machine, right? So this is the duplex forming. So some of the applications using CNC machine are door panel of automobile, headlight reflector, and all. You can see more applications in biomedical. backseat orthosis, motorbike gas tank, solar cooker, solar cooker. You can explore more designs of the solar cooker if at all you want, if somebody is interested. You can see this particular part, mechanical application in cranial plate. So you can see the cranial plate are made of a perforated sheet, right? Even some dental implants, that is to be dental plate implants are to be used. These are biomedical applications. So these are literature, and say in the one study we perform for you, for just to see the effect of CNC process parameters. CNC parameters, we perform, and we took some parameters and we investigated those parameters. So we have taken aluminum 5052 H32. H32 is a cotton hardened aluminum alloy. These are some mechanical property, and these are some of the applications of this alloy. Now we use because the way we want to use this particular machine, CNC machine, we want to know that which lubricant to be used, because whenever you use some CNC machine, you use random lubricant, then it may happen that that lubricant result into poor quality of the sheet parts. Therefore we use some 4 volt tester machine. I won't go much into detail because our topic is of CNC. Now here there will be 3 ball at the bottom, and one ball is at the top, and there will be friction, and the standard is ASTM D4172-94, and we got something like this results. And you can see that when we compare different types of lubricants together, now we can see that we use different lubricants, say 5W30, 10W30. You know better, right? Those who study tribology, they understand what is 10W30 and 5W30, the difference. The viscosity changes, and due to this viscosity, you can see that area of scar. You can see this is area, right? This is area. So the area of the scar changes. So you can see more will be the area of scar. It means that more will be the friction. Now you can see that in this coefficient of friction we reduced. Even this software what we have, this gives the coefficient of friction. You can see the coefficient of friction what we get is 0.11013 for the 10W30. Therefore, in the actual experiments, even whatever we receive 10W30, we compare with different variety of lubricants. So we use grease lubricant, we use graphite paste and grease. We found this result, and synthetic oil. Now you can see that when we compare these results, different lubricants we tried in CNC machine, in CNC machine, in CNC machine. Now when we have some set of parameters, then we found that you can see here that synthetic oil gives more phi max, more phi max. More phi max means more formability, because it is varying wall angle conical frustum. So at what maximum angle it is going to fracture? Now you can see the maximum is value is 83.51, which is the highest among all, and surface roughness is lowest among all. It means that we understand from this that 10W30 will be good for CNC operation. You understand? Then we have written here what are the properties of 10W30. So what I mean to say is, whenever you do some research, if you are a student, you have to see the history of the machine and start from beginning. Don't start in the midway, because then you will not be confident. So start from the beginning, right? And then we have some. Now you can see when you see this study has been performed to see the effect of anisotropy. Anisotropy in the metal parts are very common. So anisotropy, again, if I go detail, then it is I want to declare here the use of CNC machine. Here the experiment we perform in Indo-German tool room Aurangabad, which is a Ministry of um, micro, small and minimum enterprises, Government of India. Here we use some parts. We produce some parts. These parts are nothing but this conical frustum. This is pyramidal frustum, and you can see right hand side there is a tool. This is a 2D graph of the tool and the workpiece. Now we had the simulation, and after simulation we confirm that the anisotropy has some effect, but that effect is very small, very small. The two criterias we use, Hill 1948 and Honmeister's criteria, we use And the experiments what we perform in this CNC machine, the same experiment same parameters we took in case of this CNC abacus simulation, and we found that the error difference is very small, very slow, very low, and therefore we could conclude that the anisotropy plays very minimal role in case of aluminum alloys, and therefore we proceed our discussion with some now parametric study we perform, because we already studied lubrication, which lubricant is best. We studied whether the effect of anisotropy has to be we studied, and then we perform our actual experiment. So those who are the beginners and young researchers, I would like to tell that when you perform anything, first look at the background and study the background. जैसे कोई क्रिकेट की मैच हम खेलते हैं तो पहले क्रिकेट की मैच खेलने टाइम हम प्रैक्टिस करते हैं, so there will be a practice session, so you have some practice with the machine, you have some practice with the softwares, and then you perform the actual parts. You first learn the background of any machine, because many of times I observed in my professional career that हम क्या करते हैं, गलत रोड पे चलना शुरू करते हैं, और जब हम काफी लंबा चलते हैं, काफी लंबा समय तक हम चलते हैं, तब बीच में हमें पता चलता है यार शुरू में ही हमने गलती कर दी. So when there is a mistake at the back, it is very difficult for you to repeat that process again go back, again फिर से करो. और जब जब हम पहली बार करते हैं ना, तो हमारे बीच उत्साह ज्यादा रहता है, हम अगेन सेकंड टाइम वही रिपीट करना है आपको, तो इट फील्स वेरी बोरिंग. So young researchers, I request that whenever you do study anything, whether in your MTech or PhD or BTech, you have to study first background, ample amount of literature, and then study. Very good proverb. So, in a powerful man can fail without plan, but the weak person with plan will win. The weak person, okay, because plan is important, plan only works. So here we plan the lubrication study, anisotropy, and then we study for the performance. Now you can see that these are the parameters, and these are the forming processes which are controlled in the CNC machine. Feed rate, you can control step depth, spindle speed, tool diameter, and the sheet thickness. Even you see forming parameters, that is feed rate, step depth, and spindle speed, that is in the hand of operator, which can be controlled on the CNC unit. And here it is the geometrical parameter. These are manually we can control. Abhi tool diameter is of 8 mm, yeah, 10 mm diameter, that you can select at your own, right? And sheet thickness you can use. Sheet thickness, again, machine will not select thickness. You have to use that sheet thickness and start experimentation, right? So these are some parameters. So majority parameters, which are concern of this for the present, these are forming process parameters which are controlled on the CNC unit. And then, so now the plan of study, you can see that first the CNC code is generated using CNC machine, and you can see that this is bearing wall angle conical frustum. Here you can see that it is indicating T. T is nothing but tangent. Tangent is nothing but it is a 90 degree. So this particular angle, bearing wall angle conical frustum, is from 30 degree to 90 degree. In between there will be fracture, definitely, because if you see the law, T final is equal to T initial into sine 90 minus phi. When the phi reaches to 90 degree, there will be tan 0. Oh, sorry, sine 0, and sine 0 is nothing but 0. It means the fracture will happen. So we need to see that at what maximum extent we can prolong the fracture. That's it. Fracture to hona hi hai, but up to how much extent? So now we use CNC machine, and when we use the CNC machine, we use some parameters. And these parameters we have investigated, and we found that in case of surface roughness, the effect of again, I don't go in design matrix and all. So step depth we found very efficient parameter, and table feed we found very efficient parameter. So first is step depth. So we can see that step depth is more influential parameter than the any other parameter what we investigated, right? In case of surface roughness. Similarly, the study has been performed on the formability, because So formability study also, we conclude that here you can see the pie chart where the sheet thickness value will be very much important in case of formability. The more the sheet thickness available, the more material is available to form, right? More material is available to form, more power is required for the machine. So more material is available to form, so more will be the resistance from the material, right? And sheet fracture can be prolonged, right? So step depth and sheet thickness have a significant effect on the formability. So now we can say that we have confirmed the experiment and we found these kind of experiments and we have confirmation. It means that whatever conclusion we made, that is up to the mark for the given CNC machine for a given material, for a given material, right? So now we have seen that what is the corrosion rate we studied. So the optimal जो value आया, you see that surface roughness and the maximum forming angle, we got this optimal condition. This optimal condition is N3. What is N3, F1, P1? It means that the speed at level 3, feed at level 1, step depth at level 1, D indicate tool diameter at level 2, and sheet thickness at level 1. So these are the optimal condition for surface roughness forming angle. When we had the corrosion study, we found that you can see that the corrosion rate is increasing. So corrosion rate is increasing at the bottom. So what does it mean by bottom? It means that you see in the sample, right? You are seeing the sample. So this not here, we not mention the sample. Yeah. Now here it is said that initial of the forming, middle of the forming, and at the time of fracture. Here we had the residual stresses. Now here you can see that the residual stresses are increasing 0.0439. It means that there is very less residual stresses at the initial forming, but middle forming it is slightly it increase, and at the end it is increased much, right? So now you can see this is the difference. So we can say that the residual stress in the material, because residual stress is nothing but a compressive stress, because you are ultimately you're compressing the component, right? So the residual stress has very significant effect on the corrosion resistance. So corrosion resistance is very poor if the material is stressed. Corrosion resistance is very poor when the material is material is loaded, means it is corrosion will be high in case of residual stress is high. Mm per year, it means that 0.2791 mm वो करोड़ होगा per year. Always it is in per year. So now we had some investigation further, and because here we found that in the initial experimentation that in the case of CNC machine, we have to remove some parameters. So we even you can see in the previous figure, even you can see here the spindle speed. You can see spindle speed in the case of formability. It is very small effect. You can see the sheet thickness has significant effect, step depth has significant effect, but spindle speed has very slight effect. And even in case of here, you can see spindle speed has very slight effect. Therefore, we removed this parameter in the further course of study. So this is nothing but the process is evolving. The process is evolving. Now we not consider that, and using the Box-Behenkel method, we again found the empirical relation for the surface roughness and maximum forming angle, and we had some confirmation test, and we found the error. Similar exercise we had with neural network. This is one of the optimization technique, and we compare the result obtained. That whatever test we took into RSM, the same test results we have considered here in artificial neural network using MATLAB, and in that we use 29 set of parameters. These 29 set of parameters will be there in Box-Behenkel method as well. And here 70% data for training, 15% for validation, 15% for the testing. This is all methodology related kind of terms, right? Though some structures we use. I don't want to go in detail in the neural network. I want to show you the what you can see that the results are closely matching with RSM. Result obtained by response surface methodology, the result obtained by a neural network, and the experimental results are very closely related. And in that, you can see that the ANN and RSM model uh, uh, can be used to predict the surface tension permeability for a. So you can see that if you see the comparison and if you see the error, ANN model finds superior over RSM model. So anyone can use our model in order to predict something without performing actual experiment, because if you see the CNC machine, the CNC machine of 50 lakhs rupees, and if you want to use it for 1 hour, it cost is higher. So in order to predict the value of the opt-in, so how much will be the formability, how much will be the surface roughness for a given material, one can use the neural network model, and they can estimate. Again, it is not exact prediction. They can estimate how much will be the response parameters, right? So then we extended our study to overall performance of incremental farming process. Overall performance. So here we use multi-response optimization. Now, up till now, I shown you using CNC machine. We had forming simulation. So first of all, I will, before commencement of this chapter or topic, I would like to show you some videos that may be interesting to you to see how CNC operate, right? Without wasting much time, I just go to my screen and I will show you some video associated. Now you see this video. This is of forming. Now you can see. You've seen this kind of forming, right? So so there are many kind of forming. One additional forming I will show you is called roller forming, but it is my just for your information. Now you see this
shape. The sheet undergoes what is called a profile bending. Roll form details are very common in, for instance, the furniture, construction, and car industry. It is possible to create advanced profile shapes in high-strength materials, and many different materials can be used. All materials that can be bent can also be roll formed. Roll forming is gentle on the material and has a minimum of wear on tools. Today, the roll forming process and the tools are designed in a computer environment before production. Computer simulation is an important tool in order to analyze the roll forming process. Here, the different step fixed roll stands. It does not have an automatic feeder. Instead, it is fed manually. More advanced profiles require more roll stands in order to reach a final result. This machine shapes the strip into a simple V profile. Note that the sheet springs back. Spring back is the elastic deformation that appears after shaping. Spring back is compensated for when the roll stands are constructed, thus overbending the sheet and letting it spring back into the correct form. What the roll-forming pool looks like is decided by what kind of profile is needed. The starting point is to draw a cross-section where the required radii, thickness, and dimensions are applied. So decided in more preparatory stages before roll-forming. There is a great demand for machines that can complete as many stages as possible in a single production line. If more operations can be incorporated into the production line, large volume processing will be more cost-effective.
You understand? Now, so based upon the application, one has to select the forming technology. Cylindrical portion SPIF will not work. There we have to go for hydroforming. If you want to manufacture some roof, पत्रे वगैरह जो होते हैं वो यदि बनाने हैं, like plate kind of form in a long, means long size, say 90 meters by 90 meters or 50 meters 50. So there we use this kind of forming called roller forming. So every forming technique has its own limitations. Okay, so now I extended the study on multi-response optimization. So multi-response optimization, we use these kind of methods: SAW, WPM, TOPSIS, and GRA. Here also we consider surface roughness, forming time, sheet thinning, and the spring back. Spring back is very important because this is elastoplastic deformation. Therefore, after plastic deformation, material will try to regain its original size and shape. Not permanently, but some extent it will take. That is called spring back. So how we can measure the spring back? Suppose you deform the material. So after removing the clamps, so you remove that particular component from the your machine and measure the depth. So your depth was 90 mm, and if it shows 88.97, it means then 1.03 mm is the spring back. So again, there are different methods how we can use the spring back. I explained you a simple method where you can measure the height of the component that reflects the spring back induced in the material. We use some techniques, and here we use these analytical hierarchy processing, and we use this machine and analysis of variance, and again, so we found this kind of. So this is all about multi-objective. So all the response parameter which you want, if you want to club together, that can also be possible. Now here the one part I would like to explain. Here I studied. This is the study performed at Warsaw University of Technology, where we had they investigated two materials. One is in the aluminum series and one is DC04 series. Here we use two different series, and here you can see that K stands for strength coefficient, and N is strain hardening exponent. You can see that there is a different strength and therefore different K values and N values. I would like to tell you that when the higher value of N gives you more formability, strain hardening exponent, and these values are obtained using the tensile testing of a material, using uniaxial tensile testing machine, right? That is one different technique of using. Say for example, you have to make the curve fitting in the Excel, that need to be done. So these are constant parameter using Holloman power law, right? So you can see that Ludwig Holloman model we used to fit the model. You can see the engineering stress strain curve, and for the two different materials, then we convert into ln of true stress. Okay, the engineering stress, these are tensile tests we perform in these two materials. Then these two materials tensile test we performed, we got engineering stress strain, and we got this ln of true stress and true strain. We got this value, K and N value we obtain, and then we had performed this in laboratory of Warsaw Institute of Technology, right? And you can see the geometry, what we consider very simple geometry. Here we took 59 mm of cone, and the height is 80 mm. Right? Considerable height. Now what we had is, now you see this is a control of CNC machine. The CNC machine is different in Poland. We use that controller, Heidenhain TNC 410A. This is the name of the controller. Here we generally use Fanuc controller or Siemens controller in India, right? So here in the CNC machine, we control step depth only and See, only we change the step depth. Only we change the step depth. The step depth is changed from 0.2 mm, 0.8 mm, 1. Now you can see the forming angle is also be changed. So based upon our geometry, the program will change. The particular program is made. The program is made for step depth and forming angle. And remaining parameters are kept constant for all the tests. So feed rate, right? Or different parameters are kept constant. Now you can see very interestingly at initial time 50 underscore 0.2 it is formed, but 50 underscore 0.8 we perform it is formed. The geometry is shown here. You can see the geometry is like this. But when I take forming angle of 50, step depth of 1, it is fractured. And the fracture depth is 21.568. It means that when anyone want to form the angle using CNC machine at 50, 50 forming angle is 50, maximum step depth he can use is 0.8. This philosophy also, this is the 0.8. Why only we consider step depth, not feed rate? Because this is belongs to previous study. What previous study says? Step depth is very important parameter in the formability. Therefore, we consider here step depth, not a feed rate. Therefore, I say the thorough investigation is necessary. Your chapter number 1, chapter number 2, chapter number 3 should be interlinked to each other. हम जब बचपन में कुछ पढ़ाई करते थे तो पहली पहली कक्षा में यदि आपने पढ़ाई की तो दूसरी कक्षा में आपको समझ में आता था। पहली कक्षा ही किसी ने नहीं की, डायरेक्टली वो सेकंड स्कूल में आ गया, सेकंड स्टैंडर्ड में, तो उसको कुछ भी समझ में नहीं आएगा। सो सिमिलरली व्हेन यू राइट योर थेसिस और समथिंग, so or any research proposal maybe, so it should be interlinked. One paragraph should link with second paragraph, third paragraph. So this kind of linking is here you can see in my presentation. Now we can see that 60 0.2 60 0. Now here you can see when you go to angle 60 with 0.8 mm, now the limiting 0.8 mm जैसे हम step depth लेते हैं, the fracture is taking place at the depth fracture height of 14.456. It means that the formability is further reduced. And if you go down, you can see that even after at 63.75 forming angle, even after the step depth is 0.2, you received a fracture. You received a fracture height. The fracture height is 14.884, and it is fractured. It is fractured. So that's what I would like to tell you, that the fracturing of a material is very important. And up to what maximum extent you can speed up the process of forming, that is also very important. Because time study, you had a time study in case of operation research, time is also very important. Therefore we had a time study here. Similar, we have, you see the table number 1 and this below table, these table are similar, only except the material change. You can see the different fracture and form results in both the tables. This is we develop a zone. So for example, aluminum 5754, you can see that you can see this pink region. What this pink region indicate? It is non-formability region. It means that when anyone want to form a part with 52.5 is the maximum forming angle, he can take maximum step depth of 0.6 or slightly, you can see that 0.62, 0.63. But if it goes to 0.65 or 0.7, sorry, 0.7, if it goes to 0.7, fracturing will be taking place. Therefore, we differentiated with the curve formability and non-formability region. The study will be further extended for different kind of different materials in order to receive generalized conclusion. Therefore, you can see that customized production will be obtained. These are the graphs for average surface roughness and the hardness value. Understand? These graphs for average surface and hardness value. You see the further study is extended using CNC machine for DC04 sheet. DC04 sheet. Here you can see that these are the experimental graphs of thickness. You see how many results have took in order to prepare the precise graphs, right? So we had studied the DC04 steel. See here, We know now we take a case study of 0.2. You can see we can take formed, right? So 65 0.2, you see this stainless steel 65 of 0.2, the part is formed. Now we took this part, see 60 0.2 and feed rate is 1400. Now we know from our previous study that feed rate has more influence on the time calculation. So you see that we and step depth and feed rate gives you the reduction of time. Now we had 0.2 1400, and here we see drastic increment in the step depth and keeping feed rate constant. Now you see 0.2 0.6 1400, and here 1400 to 3000, because machine capacity is 3000. After 3000 per minute machine won't work. So by seeing the capacity of machine, we selected, say, CNC machine hai, to you have to see the limitation of the machine. Within that limitation only you have to work. So 1400 to 3000, and 3000 we took 0.2 and 0.6. In all the possibilities we had, we extended our limits, and we found that from 4338 second machining time, it reduced to 686, and the part is formed, and we compare those parts, and then you can see that the comparison in terms of surface roughness, in terms of hardness, that is nothing but material characterization. It is material characterization, right? And again you can see that I think this is for 5754. Now the study is extended for DC04. Here you can see that we drastically reduce the forming time from 4680 to 2250. You can see that it is around 60%. You can see, if you even percentage also we have described, this much is a time reduction possible. Now somebody is more interested, then they can if he or she has four choices, definitely if she understood that for my forming application I could use these parameters, they can reduce the second time. Now you can see that for one component the time reduction is around 2400 second. Then 50 components, how much will be the time reduction? Therefore I say that the study is having significant impact, and these are the these are the components what we formed using CNC technology. This is very magical technology. One has to be used very precisely, and the workshop is of 5 axis, so it is again more precise, right? So these are what I would like to present. And again I have one small presentation. Here I explain you can see, yeah. uh, I think I have some 5 more minutes that I would like to cover up some of the major application using CNC technology. Now you see that this is already been covered. Yeah. So these are different forming techniques. You can see that this incremental forming, you can see in the graph, cost will be drastically different, drastically reduced. Cost per product will be huge for less number of parts. If the number of parts are higher, you see that 300 parts, the cost is for 300 parts. So medium, we can say the medium production, one can go for incremental forming. Mass production, obviously one can go for stamping, right? Even there will be a very noise reduction. ISF, the noise is around 60 dB, and stamping is 90 dB. When that punch and die collide, उनका जब टक्कर होता है, तब there will be huge noise, and that result into lot of disease related to hearing issues with the people working in the metal industries. So that can be avoided. So you can see this is the frustum of cones, spherical frustum of cone, and the frustum of pyramids. You can see the different application. These are automotive parts, customized implant, architecture, 1/8 scale of model of front selection. You can see the human face. Human face is a very complex geometry, which can be formed using this technology. Metal forming lab, you can see metal forming lab. These are the letters, English letters are formed using the forming technique. So very innovative, right? Very innovative. section of the ship it formed, but it needs very huge machines. Now I told you this B2C, you can see the B2C portion. The B2C portion only uh, follows the sign law. Final thickness is depends upon initial sheet thickness. Now this is related to forming limit diagram using forming technology. I don't go much in detail about this. You can see that these are all. Now this is one of the limitation of forming using CNC machine. You can see the solid line indicate the actual part. Sorry, it is sorry. Solid line indicate the actual part. The dotted line indicate the ideal ideal or CAD geometry. You can see that there is some deviation. Some location the deviation is huge. Some location a deviation is very low, right? So the deviation is nothing but it is a spring back. So when the spring back will be there, it result into inaccurate part geometry. So inaccuracy hoga to definitely the part will be rejected. Therefore, attempt has to be made on accuracy, and therefore high temperature forming, incremental forming, warm temperature incremental forming using heaters. Even some of the papers I have seen the halogen bulb are used for heating purpose. So now, in order to get more accurate product and in order to have rapid plastic deformation, people are trying to use high temperature forming. High temperature forming. These are some metal forming. So I think using CNC machine, I have covered some of the portion in last half an hour. Sorry, last 1 hour. Now I request my student Dishan. He will present you how he demonstrated the CNC code in using Unigraphics software, and he will also explain you how to use these softwares for the simulation in the case of Abacus. I request Dishan, please carry forward.
Thank you, sir, and good afternoon, everyone.
Dishant, you please share your screen
Yes, sir.
to the audience.
So, first, I would like to tell how NX12 can be used in simulation and as well as in experiment purpose. The first purpose is to create NC codes that for desired geometry, and so for creating NC code, we use NX12, NXCAM, and these codes are also used in simulation, and I would like to show you how. So first, I have created this geometry, and this is a variable wall angle conical frustum, and at the bottom of this, there is a I have constraint geometrical constraint that is angle is 90 degree. So because we as I have already told you that final TF, that is final thickness of the part, depends on the angle forming F. TF equals to Ti cos alpha, and as alpha is a forming angle, so we are changing the angle, and if angle reaches the 90, so there fracture or fracture usually happens because of the alpha is 90 degree and thickness reduces to 0. So I have created this geometry, and then depth is decided for, and the upper radius of cone is decided by the fixture size. If the fixture size is limited, for instance, our fixture size, our working diameter of our fixture is 50 mm. So we have constrained it to 25 mm, and the bottom dia depends on the tool. Like we are using a 10 mm dia tool, so we have created 2 mm for clearance, so that tool doesn't interrupt our geometry. So when then we created this shell, after that we go into manufacturing side and create a tool path, because it is important for simulation as well as experimentation how tool path moves and geometry will be created according to this. Then I have chosen Z label profile toolpath because I am using plus Z toolpath for this. There are two different types of toolpaths for creating a geometry in SPIF process. One is spiral and another one is Z plus Z. So I am using plus Z label toolpath. That's why I have chosen Z label profile to generate toolpath. After that, I have also created a tool according to which I have given the dimension of tool. That is, for me instance, my tool is of 6 diameter. So I'll put some. And this tool is created. Then I have given for me first we have to do is mill rough, or we can do you if we have to improve the surface geometrical constraints, so we can use mill semi finish because it will increase the geometrical accuracies. Then we define the top level, that is from where the cutting has to, or SPI process has to be done. Then we also define the bottom level. So I have given the depth because I have decided that my conical frustum will be of 40 mm depth. So I have given the range depth of 40 mm. And I also decided that it should start from there only. Then this is my maximum distance. It is the depth per cut. So step depth, also known as step depth. So the distance between two contours of this of tool path will be 0.5 mm. So I like to show you. So the distance between these two contours will be 0.5 mm. We can vary these, but for my project work, I have kept it to 0.5 mm. Then I have generated a tool path for mill 3-axis numeric 840D MMPUI. So depending on the machine you have in your college, you can change the file type for CAM processor. So we have a numeric tool path machine. So we use this. Our MMPUI is the unit. So I am using mm. So I can use MMPUI, or you can use IN, that is for inches. Then these this is a CNC code that has been generated by this NX12. Then I have imported this tool path into Excel sheet and remove this N series N010 because it is irrelevant for a CNC machine. So I have removed this, and also converted this tool path into X and Y and Z coordinates. So these coordinates are very important for me. That's why I'm going to use these coordinates in simulation work. So I have converted this file into this because in Abacus CA, it could not able to read these only. Abacus could only use to read numbers. It couldn't read X with before the number. So I have removed X from these number and converted into an Excel sheet of containing X, Y, Z. Then I have also decided to give the time to which process has to be done. For it is known as step time. That each step there will be a time for X coordinate, movement in X coordinate, movement in Y coordinate, and Z coordinate. So now I'm going to open my Abacus. So because of time constraint, I'm going to show you from the overlook only. So first, for a sheet, it is decided to be deformable because our sheet is going to deform, and there are other options like discrete rigid. But discrete rigid, it is used for tool that that is not going to deform easily. And analytical rigid, it is also used for the tool and depending on the requirement. So I have created a geometry of sheet for like to show you. So this is the dimension of my sheet, 92 by 92 mm. So I have created a sheet of shell and of deformable nature. Then I also created a tool. It is also a shell and also of analytical rigid. That's why you can see this is hollow, but because it is analytical rigid, there won't be any deformation. So it will remain intact. So it won't be an issue if you make it a solid or nothing. Then this is a support. That support is very important for, because if there isn't support, there will be a bending or another geometrical inaccuracies like spring back. So support provides gives dimensional accuracy to it. Then I have defined the properties. First property that is more important is 8E6. As the material is stainless steel 316. So I have given the mass density. It is 8,000 kg per kg per meter cube. So I have converted into this unit. Then this is as all units. First, most important thing while performing as emulation is the units. We have to keep in mind that all units should remain uh, in same format. Like if you are operating in Newton per mm square, so keep every unit in that format. So that's why I've kept Young's modulus 193,000 and Poisson's ratio plastic. In this, we have used Johnson Cook plastic model because strain rate is keep on changing in our project. So we have to use Johnson Cook plastic model for predicting the plastic deformation. And for the prediction of damage, how our product or our sheet will damage while tool moves on it. So we have used Johnson Cook damage model. It also covers the void nucleation, void coalescence, void nucleation, and stack propagation. All this covered in Johnson-Cook damage model. Then we have given the fracture energy. What energy this sheet or material, it is a property of a material that it gets fracture. After that, assembly is created. I have assembled with how it, in real, this is also same. That sheet is put on a fixture or a support, and then sheet is clamped on all edges, and the tool is free to move. So there is, and a step is defined. It is a dynamic explicit step, and first time period. So this is a total time that is being generated depend upon the feed, and we have decided in our Excel sheet that our total time will be 1500 seconds. So that's why we have given time period in step. And other most important thing in this mass scaling. In this our total time is divided into steps, and this depend upon the mass scaling and time scaling factors. So for scaling factor, we have used 0.01, that our 1 second will be divided into in each step of this number. And for this, we have kept the time scaling or time increment to be constant throughout the whole process. And in this field output request manager, all the property or the result we are request from a request, we can tick it in it. For instance, I like to see section thickness, so I have ticked the section thickness option in this field output request. Same we could do with other like failure, damage, tensile damage, stress, strain, whatever output you want from this abacus, we could get. And also you have to change the interval in here. Then interaction. And in interaction, we have to define the relation between tool and sheet and support. First, I have given the relationship between tool and sheet. So I also have to create the properties for tools, how interaction will be there. So first, I've given the property surface to surface explicit contact. So in this surface to surface explicit contact, I have given penalty friction formulation penalty, and friction coefficient I assumed it to be 0.1, as earlier it was decided by results mentioned in some research paper and others. So I have kept it 0.1. Then it also has normal behavior. There are two behaviors while in contact between the tool and surface, that is sheet surface, that is tangential behavior and normal behavior. It all, and the friction coefficient is considered to be 0.1. Then load. In load, we have defined that sheet is clamped. So we have kept the boundary condition of sheet to be clamped, that it is fixed from all sides. There is no motion on the edges of the sheet. Even no rotation, no translation motion at the edges of the sheet. Same we have clamped the fixture, that support, that is to be clamped, and then we have given the motion to the tool by using the boundary condition. Here in amplitude, we have given these coordinates of x, y, z that are being mentioned in. Wait, let me show you. Yes. So I have created an Excel sheet that contains the amplitude, or I would say the x coordinates. So these coordinates along with this time is mentioned or given as the input for the tool movement in amplitude. So in this way, I have given the input for x, y, z for each tool path. So this depends upon the tool path. If you change the tool path, it will automatically change. You have to input it, so it have to change by you. Then I have to do the meshing. So I have generally use the quad dominated meshing. Meshing are of two types, tri and quad. So as it is a simple geometry, that's why I used quad. If there is a certain circular in here, so I have to use a tri, and also that's why it is so structural geometry. So this way. Then you have to create a job, and as the request output you have requested from the abacus, so these requests will be results will be shown here. So this is the output I get from here. Wait a minute. That's how in real I have shown the video that tool is moving such a way, and in simulation also tool will move in such a way, and I have to fast forward it a bit. So in this way, the deformation keeps on happening, and it is a variable tool path. So our deformation will, oh sorry, fracture will occur soon. So see, where fracture occurs. As soon as the angle reaches the forming angle, the limiting forming angle, fracture occurs. So you could also get the results from there. Like I have another file. I've kept some results. Okay. So you could create a field output. So you can get depth versus displacement along the path. So you see there is a bending here. So you could also predict. So you could also define dimensional accuracies with the simulation. Also, you don't have to perform an experiment to find the dimensional accuracy, spring back, pillow back, etc. And also you can predict the depth of our sheet or a material depending. So this is thick, and you could also get the section thickness here. So the section thickness graph is such a way that first it decreases, then there it happens at the center of there is no movement of the tool part. I would like to show you geometry first. See here, the center of there is no movement of the tool. So thickness will reach thickness is original thickness, that is 1 mm. So that's why the graph is such a way that it reaches 1 mm thickness again here, then deformation because tool starts moving again and thickness decreases. Then again this way, and thickness also depends upon the angle. So it is a variable conical frustum. So angle is changing, and so way our thickness is changing. At certain time, our thickness will become 0 because when angle reaches 90 or limiting forming angle. So in this way, abacus could also be used to predict results like depth, thickness, section thickness, etc. So here at this point, the thickness will reduce to 0. So that's how abacus can be abacus along with NX can be used to predict or failure in SPIA process or incremental process, and also predicts results like section thickness, forming force, and also it can be used to predict forming force and depth of the depth as there is a thing, depth depend upon the material, and if the material changed, so it's very difficult for you have to or you have to do is to perform an experiment that will be costly, but you can use abacus to simulate the depth, and it will give you the result. And most of the time it is pretty accurate. It depends upon the data you are giving. So it will save your time, because simulation will take only a 2 hour to perform, and while performing an experiment it requires capital and other things. So that's why a simulation is very helpful for predicting damage and failures. Thank you.
Yeah, so that's from our side. If you have any question, please let us know.
Thank you, sir.
I think no question from the participant.
Yes, sir.
Okay. Can we leave the meeting, madam?
Yes, sir.
Thank you so much, sir.
Thank you.